Hello, 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 dear participants of the PWA Summit 2022. I'm Maxim Salnikov. I stream directly from Oslo, capital of Norway, and my friend Diego is helping me today. Diego, could you introduce yourself?
I'm Diego Gonzalez. I'm a PM at Microsoft team, and I'm streaming from quite moody London. But hey, it's not such a bad day.
Yes, I'm in Oslo actually, and like Diego, I also work in Microsoft. But this is just a coincidence because PWA Summit is organized by people from multiple companies, and you'll see our sponsors or organizing partners on the next slide. But now I want to tell you that this year we organized PWA Summit actually like three in one event. We'll have 3 blocks of technical sessions distributed over time, so to be friendly for all regions on our planet. And feel free to join all 3 of them. They will have different links on YouTube, but we'll keep you posted, and I hope that you have all 3 links in your emails sent by us early, and we'll post that on Discord and everywhere else. So you'll find where to join us, and you'll find full schedule on our website, pwasummit.org. Now,
as Maxime was saying, PWA Summit is made possible by the efforts of a lovely group of people. We're a bunch of folks from Google, Microsoft, Intel, and Samsung, and we are completely delighted that you're able to join us today and learn a lot about PWAs.
And let's chat, let's interact. We are keen, and our speakers really want to hear from you, and we as organizers and workshop trainers and speakers want to hear from you on Discord. So this is our official channel to communicate, and I hope that majority of you joined this server. This is a link you see on the screen how to join this, and I think we'll also post it one more time on all our social medias. And after joining, you will find channels dedicated to concrete technical talks from our schedule, and this is the place where we expect your questions to our dear speakers, and this is the place where we'll ask our speakers go and answer right after they completed with their presentation. And of course, let's be friends on social media. We have Twitter PWA Summit, and we have special hashtag PWA Summit 2022. So post something about our event, and maybe post your selfie, how you watch us, and post where are you watching us from, whatever you want to share with us. Let's stay connected.
So let's stay connected, let's definitely interact, but let's be friendly. And there is a code of conduct. And here at the PWA Summit, we require everyone to be respectful to each other. We want especially everyone to treat everyone with respect, and we need to participate while acknowledging that everyone deserves to be here. If for any chance, and I hope it doesn't happen, there is any issues, then you can report them to Aaron, Laura, or the organizers with the emails that you see on screen. If you want to see a full version of our code of conduct, then please go to pwasummit.org/code of conduct. Now, with that out of the way, then we can actually get the show started. It's been already a very busy morning with workshops, and now it's ready to dive into with our first batch of speakers, Jeremy, Laura, and Kenneth.
Take it away.
Excited I get to be here as the first presenter in this session. My name is Jeremy Scheff. I'm an indie video game developer, and all of my video games are PWAs that make pretty heavy use of client-side data storage. So that's why I'm here giving this talk today. I want to talk about both the current state of data storage as well as where things seem to be headed in the future. So let's just jump right into it. If we're talking about data storage today, we're mostly talking about IndexedDB. That's the main way we have to store a large amount of data client side. And there's some good things about IndexedDB. You get some high-level database features like indexes and transactions, very useful. There used to be a lot of criticism about certain things in IndexedDB, such as cross-browser support. That was an issue for a long time. Not so much anymore. The past few years, we have pretty good support in all the major browsers. There used to also be a lot of criticism about IndexedDB's API. It has this kind of, idiosyncratic event-based API because it was standardized before promises existed. But these days, there are pretty nice wrapper libraries like IDB and Dexy that lets you get a nice promise-based interface to IndexedDB. So some of those kind of common criticisms of the past no longer are huge issues for us as application developers, but there are still some limitations when we're using IndexedDB. And I'm going to touch on all these limitations that I have listed here at different points of my talk. But I kind of want to start by talking about this last one, complex queries. And so what I mean by complex queries are if you want to do the same types of things you do when you're working with a SQL database. If you want to do joins, you want to do aggregation, you want to have foreign keys, whatever SQL type stuff you can think of. For the most part, these are not supported out of the box in IndexedDB. You get, as I said on the previous slide, transactions, you get indexes. That's kind of about it. And so there was some talk about this back in the days when IndexedDB was being standardized. People were wondering, is this a high-level database? Is this a low-level database? What are we really building here? How are people going to use this? And one argument that people would make is that, well, yeah, it might be kind of low level in the sense that we don't provide you all the features you get in a relational database, but you could imagine building a relational type database on top of IndexedDB and getting some of these, fancier types of queries in some layer that exists above IndexedDB. In practice, how has that played out over the past decade or so? You can find examples of people doing some clever things with indexes and cursors to make queries that you might not think IndexedDB could do out of the box. But for the most part, it's nothing approaching what you can do with a SQL database. And this is kind of a challenge if you're building a application that makes kind of heavy use of the types of features that you would want from a relational database. But within the past couple of years, there have been, I think, some very exciting developments that give us some idea about how things are going to look in the future. So there are these two libraries I have listed, Absurd SQL and PWA SQLite. And what both of these libraries do is let you run actual real SQL queries on top of data stored in IndexedDB. So, that's, things are getting a little exciting here. When we think about that, that's kind of, what a lot of people wanted in the first place and what a lot of people have been, hoping we would get to the point of being able to do. And it seems like, we are getting there. So these libraries I mentioned, what are they doing to run SQL on IndexedDB data? Well, what both of these do is first compile SQLite to run in the web browser. And this in and of itself is not a new thing that, people have done that, for years. But in the past, that was working on an in-memory database. So you could load data into SQLite, you could query it, but then as soon as the user closed the browser tab, the data was gone. So what these projects are doing differently is they are hooking up the backend of SQLite to IndexedDB so that the data is being persisted the same as any data you write to IndexedDB. So this is really cool because you kind of have the best of both worlds. You have the ability to query the data in sophisticated ways like in SQLite, but you also get persistent data in your PWA. And you might think, well, how does that actually work in practice if you're running one database, SQLite, on top of another database, IndexedDB, that's not really normally the way that things are implemented. Like, is this going to be really cumbersome or slow or something? And actually, what has been found, and these graphs I took from this blog post I linked to from James Long, who's the author of the Absurd SQL Library, and he found that writing queries to query your data through SQLite on top of IndexedDB actually ran faster than hand-tuned queries accessing the IndexedDB API directly. So it's not necessarily true that doing something like this would result in bad performance. So it's kind of a pretty promising technologies, I think. Of course, there are some limitations or challenges here as well. So first, I think it's kind of fair to say that all of this stuff is kind of experimental at this stage. Like, both of those libraries I mentioned are pretty much projects made by an individual developer. I'm not sure if they have much production uses at the moment. They both give you kind of a large bundle size because you have to ship a whole copy of SQLite with when you're using it. And actually, I noticed, I think just like yesterday or a couple of days ago, somebody had done something similar with Postgres, letting you run Postgres client side and storing the data in IndexedDB, very similar to what I was talking about with SQLite. And doing that with Postgres resulted in like a 30 megabytes bundle size. With SQLite, it's probably it's less than a megabyte. So maybe not the end of the world with SQLite, but still a concern. And then this third thing I have listed here, so on my first slide, one of the limitations or challenges with working with IndexedDB now is related to data persistence. And if you have something on top of IndexedDB that's storing data in IndexedDB, you still have the same concerns there. And I'm going to talk a little bit more about that now. So when I say persistence, what do I mean here? So what I really mean is, like, can you rely on your database? Like, if you write some data to the database, then sometime later you try to read the data back, is your data still there? And of course, as programmers, we know that there's no such thing as 100% guarantee. There's always some risk that something will go wrong. But you can still think about different situations, different technologies, like how likely is it that something will go wrong? What are the circumstances in which something may go wrong? What do I need to prepare for? What assumptions should I be making? So with IndexedDB and kind of PWAs in general, a lot of people see client-side data storage mostly as like a cache, like a temporary cache of whatever I'm also storing on the server. Even if you see it this way, it's still really important to consider, these data persistence issues, because you can imagine there's some client-side data the user has. Well, what if the data gets lost or corrupted before you're able to sync it to your server? Or, what if the user expects some data to be available offline, like before they're getting onto a flight, and then, somehow the client-side cache is lost or corrupted, and now that data is gone. That's not a great user experience. But there's also, as I'm showing on this slide, some use cases where, as a PWA developer, you might want the client-side data storage to be the primary data storage. And, that kind of hits close to home for me as a developer of free video games that store a lot of data client-side, because, that's kind of the use case I have. And just to give a little more detail of what I'm talking about here, so this is a screenshot from my most popular video game, which is called Basketball GM. And in here, you are managing a simulated basketball team. And it is a purely single player game. So you can simulate as long as you want. You can, simulate tens of years of simulated basketball, or hundreds of years, thousands of years, and you can still retain all of the data from your past exploits, and you can analyze it and view it and compare it. And as a free game, I don't really want to be storing thousands of seasons of data for my users in the cloud. That's kind of both for financial and performance reasons. It's a lot better to have that data client side. And so currently I have all that data sitting in IndexedDB. And, for the most part, it works. You can keep throwing data in there and it keeps running. But you do run into some situations where you have inadvertent data loss. So how can this happen with IndexedDB today? So if you're using like, a public device like in a library, or if you're using like a private browser tab, there's not really much that you can do about that as a developer if, that's what your user is doing. But, I think that's okay. I think, users kind of understand what they're getting into if they do something like that. But these last 2 points here are a little more interesting, I think, because these are more like unique problems that we as PWA developers face that, a lot of native developers might not have to deal with. Sorry, messed up my slides. Yeah. So yeah, that middle one there, if the user manually clears their browser data, so that could happen in like a few different ways. It could be like the user is, clearing their data within their browser settings. Maybe some website's not working well and they're trying to do that to fix it. Maybe they're trying to clear up some space. They could also be using some kind of like external junk clearing program on their computer, and they might not realize exactly what it's doing. For the most part, an end user is not really going to understand the distinction between, my data is in a client-side cache, my data is client-side only, my data is on the server, my data is on a file on my hard drive, my data is stored in my browser profile. They're not going to have a great idea of that. They might not know what cookies and other site data means in the browser settings, and they could wind up accidentally deleting data without realizing it. And then this last point I have here, eviction. So that's what happens if your browser notices your disk space is running low. It might say, hey, if I have some kind of transient, non-essential cache data, maybe I can just delete that data and free up the disk space. And the user's not going to run out of hard drive space, because it's really bad to run out of hard drive space. And this is mostly an issue on mobile. And personally, given what I said about how my PWAs work on the previous slide, I do get complaints about both of these issues, mostly from people on using it on mobile. But these are kind of real problems, and people can accidentally lose their data and be confused about what is going on. So what can we do about this? So one thing that's out there is this persistent storage API, and it's pretty simple. Like, there's just one line of code on this slide. You call that one function, it returns true or false. And if it returns true, that means you have successfully marked your data as persistent. This means that it will not be evicted if the device is running low on disk space. So that sounds pretty promising. And Safari recently added support for this. It's supported in all the major browsers now. However, in practice, I've found a lot of challenges dealing with this. So one is that, at least in Chrome, it's not like a normal permission system. So by that I mean, like when I had to share my my screen and my microphone and my camera today, Chrome pops up a little notification like, do you want to share this with this website? When you use this persistent storage API, it does not pop up a notification and ask. What it does is use some heuristic behind the scenes to figure out, do I want to accept this request or not? And if it says yes, then it's great, because you get persistent storage and you didn't have to bug the user about it. But if it says no, it's a little tricky, because your hands are kind of tied then. Even if you tell your user, give me this permission, enable this thing, it might still not work. So that can be kind of confusing if you get into a situation where the user wants to enable this feature because they want their data to be persistent, and they can't figure out how to do it because the browser won't let them. Another challenge here is that this only works with eviction. So this will not do anything about clearing your browser data in any way. So that can still happen even if persistent storage is enabled. So it's like, it's called persistent, and you may call it persistent, when you're sending some notification to the user, but it still may be deleted if the cache data gets deleted. And then this other issue listed here is that it may not even completely help with eviction. I'm a little fuzzy on this, but I've just gotten like a number of reports from users that will say something like, I enabled the persistent storage in my settings, and then the next day I went back and checked, and somehow it became disabled, and I don't know what happened. I didn't do it. Or they'll say I enabled persistent storage, and somehow the data still got evicted, and I don't know what happened. And personally, I'm not exactly sure what's happening in these situations, but in practice, I think the big picture is that this doesn't really solve all of the problems that apps like mine are having, and that my users are having. So what else is out there? So there's this thing called the Origin Private File System, or OPFS. This is a pretty new technology, and what this lets you do is write your JavaScript code that interacts with files, pretty similar to interacting with files in other programming languages. So it's designed for kind of like high performance reading and writing of data from files. Now the catch is that these are not real files. They are they appear as real files when you're working with them on your website, but no other websites can access them, and even the user can't really access them outside of their website. Like, they don't generally appear in some standard place on the user's file system. They're really just for your website, for your domain. And that's what the Origin Private part of Origin Private File System means. And overall, I think this is really exciting technology, especially if you think in terms of what I was saying earlier about these SQLite on top of IndexedDB libraries, because this type of backend would be a lot more similar to how SQLite and other databases work in native apps. So potentially, you could imagine it working a lot more smoothly, a lot more easily, and a lot faster. And while I was thinking about this presentation and what exactly I want to talk about here, I noticed that the Chrome development team made this announcement that they were going to start working on a kind of official library for running SQLite on top of the OPFS in conjunction with the SQLite developers. And I think that's also pretty exciting news, because I think then you get a better chance for bringing publicity to this stuff and getting like a well-supported library. And I'm not sure what progress has been made other than announcing that this project is going to happen, but I'm very excited to see how that plays out. But then so I also like I was talking a lot about the persistence issues in IndexedDB previously. So what's going to happen with persistence in the OPFS? So one thing I've noticed in the spec is that it says clearing browsing data will not affect these files in any way. So that's pretty promising, because like I was saying about the persistent storage API, how that only affects eviction. It doesn't affect, somehow the cache data is cleared. This is addressing that other problem. So now we potentially have solutions targeted at, both sides of this, inadvertent data loss problem. However, and this is kind of just speculation on my part, but I'm still like a little bit, nervous. Like, is eviction still going to be an issue? What's exactly going to happen there? Because you can imagine, you have a website that stores a ton of data in the OPFS. The user doesn't visit that website again for a really long time, and then the browser realizes disk space is running low. I feel like it's going to be tempting for it to delete these files or something, because these aren't real files. These are these kind of pseudo fake files, private only to this website. But yeah, like I said, that's kind of speculation on my part. I am hopeful that through these technologies, we are ultimately going to be able to operate on data in our PWAs, client-side data specifically, with the same level of confidence and sophistication that we can in native apps. And so with that, I just want to highlight some of the questions that are raised from this talk that I think are going to govern how this stuff plays out in the future. So when are all browsers going to have OPFS support? Because, as PWA developers, we generally want to support all the modern browsers. And I'm mostly talking about Firefox here. But yeah, I think we're going to need to see support in all web browsers before this becomes like a real mainstream thing. I'm very excited to see what Chrome and SQLite developers come up with in terms of a SQLite on OPFS library. I am somewhat anxious about, what is going to happen in terms of persistence. Are we really going to be able to solve these issues and build these kind of sophisticated client-side data PWAs? And, is anything ever going to be able to be done about bundle size, or are we going to have to be shipping an entire database engine with any PWA that we want to operate on client-side data in a relational manner? And if so, it's not the end of the world necessarily. SQLite is, fairly small as these things go, but yeah, it'll be interesting to see how that plays out. And with that, I am concluding my talk, and please reach out to me if you have any questions or if you want to talk more about any of these things. I am on the PWA Summit Discord, and I'll be switching over there to see if anybody's saying anything after this talk. And also, if you enjoy nerdy sports video games, check out one of my PWA video games, but please only after you have already listened to the rest of the talks in this session. So yeah, thank you for listening, and yeah, that's all I have. Bye.
Hey, what's up, everybody? I hope that you're doing very well. And PWA Summit, very excited to be here. This is the second year that we're doing this between other folks from Microsoft, Edge, in my case, Samsung Internet, also Intel is with us. So this is our second talk. I'm not gonna talk that much. The idea of today is that check how are you doing with PWAs. This is an open conversation to the audience, and we're gonna have like before and after. So today you're gonna learn a lot about PWAs, people that have different experiences and create their own product using PWAs. And also, if you are new here, this is a way to demystify a lot of things that we usually think about PWAs. Let's check it out. So, first of all, let me introduce myself. My name is Laura Morinigo. I'm a web developer advocate for Samsung Internet and also a Google developer expert. You can find me on Twitter. My Twitter is thisislalaok. And I will be also in our Discord if you have any questions around the summit. So what we're going to do today, I need your participation. This is not only my talk, this is also yours. So we're going to play a little game here. You need to go to slido.com, put this number, and we're going to have a little quiz. So we're going to demystify some of the things related with PWAs. And also, we're going to check what else can we know or what's new. And then, of course, you're going to reinforce all this knowledge because we have amazing speakers that are going to share with you their latest knowledge and topics around PWAs. Cool. So I hope that if whenever part of the world you're in, you can join us at slido.com. Please put this number and we are ready to go. Okay? So while you're trying to join with slido.com, let me tell you a little bit about what I do. So I work as a web developer advocate for Samsung Internet. What is a Samsung Internet? It's a browser actually that is based in Chromium. So we are also major contributors of Chromium. And let me share with you that we are really committed to have and open web, and also get the most advanced features in modern browsers, which that includes respect users' privacy and, of course, push progressive web apps. Okay, so after these commercials, let me see. You can join me at slido.com again. Put this number, and then please, to break the ice, in which part of the world are you? Well, in my case, I'm from Argentina, but I live in London, so I count as both. Oh, I think I forgot Europe, right? Well, whatever. So and actually we are in the blog from Europe. Apologize about that. This is like an icebreaker. So if you're in Europe, please let me know in the chat or in Discord. Again, this is an icebreaker, and yeah, completely my fault. So let's see in which part of the world are you. A lot of people in North America, Asia, Africa. Remember that this is the first block, and this is a different time zone. And then later we're going to have a different time zone for the folks that are more in the Americas. Great. And then the other thing that I would like to know about you is that if you have any experience coding or participating in PWAs. Okay, I can see that there are a lot of people that already have some experience. Again, if you don't have any and you're like, what am I doing here? No worries. The idea is to give you the tools and knowledge so you can start, or maybe share with other people in your community what did you learn from these events. Okay. Right. So, okay, I think I have a lot of experts over there. Great. So let's start with the first quiz. So right now, what we're going to do is asking you specific questions about PWAs. Yes. Hello, everybody. Okay. So this is a very specific question. It says, do you need specific tools or frameworks to build a PWA? This is something very interesting because we need to check, okay, what do we need to build a PWA? Is it something new? Is it something that somebody created? Let's see, what were your answers? True and false. Okay, we got some people that, so yeah, it's false. It's false. And let me explain you why. Progressive web apps are just an advanced web app. The only thing that you need is HTML, CSS, and JavaScript, okay? Of course, you can have specific features, specific capabilities, but to build one, you just need HTML, CSS, and JavaScript. Of course, if you're working in, let's say, a specific framework or something like that, you can add these to your product. But again, you just need the basics, HTML, CSS, and JavaScript. Probably if you're at home and if you're an advanced user about PWAs, you're wondering, wait, but I use a certain kind of tools that really help me to develop or to check my PWAs. Well, that is also a very good resource. The idea is that you have the chance to use these tools that make your life easier. That doesn't mean that you mandatory need it, right? You can just build a PWA with simple HTML, CSS, and JavaScript. And when I say JavaScript, I mean vanilla JavaScript. You can build a service worker from JavaScript, and you don't need anything else. But again, the more advanced is our app, the more things that we need to check. And right nowadays, it exists a lot of tools that is going to help you to speed this process. For example, I cannot recommend enough PWA Builder. You're going to know more about PWA Builder during this event. Workbox, of course, your favorite dev tools in your browser, and Lighthouse. Okay, so besides the web tools that we already know. These ones are going to help you specifically around PWAs. Let's get ready for the next one. This is very controversial. PWAs can coexist within native apps. Let me check, because I don't know if there's any Android or iOS developers out there. You're probably wondering, what's going on? Is it something that I need to be aware of? True and false. Okay, so the folks that said true, you're right. Something that I need to say is that PWAs are not like something that you need to choose between your native app and then your web app. The idea is to bring more resources to the user. At the end of the day, web apps in general are very easy to code, are open to everybody. The final user doesn't have to install anything, so you can have more user retention and so on. The idea is to use the powerful resources that we have by the web. So in this case, I can tell you, for example, Pinterest. Pinterest has a PWA. That doesn't mean that they destroy the native app or anything at all. They have both in their product. So users that use the web can still access to the product. And at the end of the day, the cost of creating a web app comparing with a native app can be much more easier. And of course, you're going to have a lot more retention, and your audience can grow because, again, the web is a powerful place to share with other people. So, okay, again, for the folks that are building native apps, it's not like, oh, PWAs are like my competitive things or whatever. No, they can be at the same time. Okay, next one. So what is the feature that enables installability? As you know, PWAs are well known because they have native app-like features, including install. So for installability, you can have an icon very similar as you would have a native app. So in this case, let's see, very good, manifest file. A manifest file is the one that is going to allow you to have an icon and some other features related with design in your PWA. Okay, but what is it, a manifest file? How do I do with my own web app? So a manifest file is just a JSON. It's just a JSON that is going to have attributes and values. And in this case, I'm just showing you a few. You can have a short name, and the one that is most important is going to be icons, because there is where you're going to put images, the image of your icon, and it's going to be available for installability. So manifest file are the ones that are responsible for installability and also some things related with design. Okay, next one. What else do we have? PWA's capabilities are enabled in every browser. What does it mean? Can I use a PWA in every browser? Let's see. I hope that you are participating at home. Okay. Okay, 50-50. Okay, cool. So let's see, it's false. We wish that every PWA capability should be in every browser, but that's something that we need to keep working on. Browser compatibility is a challenge. So whenever you're building a PWA, you need to test in different case scenarios, not only in different browsers. You need to test it in desktop, you need to test it in your phone, and also in other devices. Let me give you an example. If you're using desktop, Safari and Firefox do not support PWA installation. in other browsers, let's say Chrome, you can have it and that is available, but in other browsers not. So keep an eye whenever you are going to build a PWA, which are the current features that are available. How do you know that? You can check in the browser features that are available, and then see, which are the current state of each of the capabilities of a PWA in these browsers. Next one, which of these solutions you can implement for client-side storage? If you already paid attention to the last talk, I think you can have this one very well. Let's see. Web storage, IndexedDB. I can see that most of you paid attention to Jeremy. That was very good. Web SQL, cache storage. Okay, so almost every of these techniques, but Web SQL. Because why? Because Web SQL is currently deprecated. This happened not so long ago. So the ones that are available right now are as I said, IndexedDB, web storage, and cache storage. IndexedDB is very, very interesting because it's going to allow us to have a client-side storage and with very well advanced queries like NoSQL. So I suggest to take a look into that because there are a lot of things going on into IndexedDB. And also, if you miss it, check what Jeremy had told us about IndexedDB and everything that's going on with client-side storage. Okay, cool. Next one, service workers are applied to enable fast loading. I know that service workers can be a topic that most of us developers are a little bit afraid of. And sometimes we're wondering, how can we implement this? So let's see. True and false. Okay, this is tricky. I need to admit that I put this as a tricky question. In this case, I just say false because there is something that I need to demystify about service workers. Service workers are not only for fast loading. They have many different other features, including offline access, push notifications, and fast loading. Okay, so all these three things you can add it in using a service worker, okay? Remember, these service workers are not just only for offline access. They're not just only for push notifications. They're also available for making your web app fast, also have some offline caching and push notifications, okay? Okay, we're almost at the end, and right now we're gonna check this one. The event that lets us intercept every network request made by the PWA in the service worker scope is. So you know that you have different steps in your service worker, and there is one that makes all the magic. So let's check. Is fetch. Very good. Most of you were right. Is fetch. Fetch is the one that creates all the magic, that allows you to bring your resources and manage your resources from your network. And then you can decide what you're going to do with those resources. So again, if you want to know a little bit more about how this is working, please stay in this event because we're going to talk a little bit more about service worker. Okay, next one. Which are the criteria for installability on Chromium browser? So besides the manifest file, we know that we have some certain kind of criteria so your icon can appear nice and smoothly in your platform. So in this case, let's see. Right, so the only thing that we need, if you want to make sure that in Chromium browsers, so please remember this, Chromium browsers are gonna show the installability option in your website. Besides applying a manifest file with an icon, you need to have HTTPS. Your web app needs to be safe for the user, a service worker, and at least one fetch. You don't have to have an offline web page fallback. Ideally, do it because I think this is a very good practice, but at least you need to have one fetch using your resources whenever you don't have a reliable connection. Okay? I think this one is the last one. So let me check with you. New progressive web apps features relies on vendors' browsers only. Is it true or false? Is it something that, I don't know, some vendor created, or what's going on here? Okay, true and false. Okay, very good for the ones that says false. This is also a call for you. Okay, I think this MO made most of the questions. This is like the leaderboard. No, it's like Fair Moon. Fair Moon, congratulations. You're number one, the fastest, and the ones that get most of the questions right. Okay, so let me go back to this one. There are a lot of new features that are coming, and we need your feedback. There are things like Project Fugu. There are a lot of things, for example, related with IndexedDB that are happening in Web Apps group in the W3C. If you really want to have a new feature related with PWAs, you can check in Chromium Issue Tracker. So at the end of the day, this is not only a vendor's thing. This is not only that somebody in the browser does it. The idea is that new users and developers also participate in this conversation. Again, everything that you see here, Project Fugu, Web Apps Group in the W3C, the Chromium Issue Tracker is open to everybody because we need your feedback about how we can create better PWAs and, of course, at the end of the day, have a better web. So with this, thanks a lot for participating, and I hope that you enjoyed this very first part. This was also if you were having your coffee. I hope that you wake up a little bit if you are like after lunch or whatever part of the world you are. Hopefully you can stay with us because you're going to learn a lot about PWAs. You can find me on Twitter in this with the name This Is Lala OK. And I'm part of Samsung Internet. So hope to see you around, and thanks a lot for coming. See you with the next speaker. Thank you.
Hello and welcome to PWA Summit 22, everyone. My name is Kenneth Christiansen, and as you probably guessed from looking at my background on my slide, I work at a company called Intel. So I'm here today to tell you about why we at Intel believe that creating modern progressive web apps is a winning combination for creating great desktop experiences. We often call this for clients at Intel. So first of all, let's look at the vision at Intel. The vision at Intel is that we see the web as an unquestionable key application platform. So we really want to work on this is the vision we see for the web, where we want it to go. So we want to make sure that it offers the best building blocks for creating applications. And that the application will have like very close to native-like performance and also offer all the capabilities that you need for creating these applications. So for instance, if you have an application that you want to measure your heart rate and that requires Bluetooth, obviously you would need the capability to connect to Bluetooth devices on the web. We also know that the web offers a set of unique strengths that sets it apart from, for instance, other native apps like Android apps or Windows apps. For instance, everything is just a click away, a link away. You can share these links with your friends, family, and instantly you're into the experience. The web is also designed to be safe because you visit a lot of different websites every day. So it's very important that you don't get hacked and you don't lose your other data, like access to your files in your system and all of that. So we want to strengthen these core benefits of the web as we're trying to make it more of an application platform. So we think that the web is really on the right path. It's really becoming a great platform for creating apps. And we see that with all the examples of applications coming to the web. We have a solid building blocks for creating progressive web apps, such as the web app manifest that Laura just mentioned, and service workers, but also for doing like great layout. We have new features as CSS grid, container queries, and the like. And we see a lot of design systems today being built with web components. And things are really getting better and better. One of the things that has annoyed me a bit is like when I was creating like single page applications, I really needed, like, you have to deal with URLs, the session history, and it was really difficult to make this nice transition from one clicking on, for instance, on the video and having go full screen and all of that. But all of this is being solved as well. We're having new APIs as URL pattern. I actually wrote a polyfill for that. There's the navigation API, a new replacement for session history, and there's even like the shared element transition spec coming soon that allows you to create all these nice animations. So I think we're doing really, really well. We also have a relentless focus on performance. So we're having WebAssembly today that allows you to take your existing code, for instance, Rust, C++, C code, bring it to the web. Or if you see that there's a bottleneck in your application, you could rewrite that in native code and have it perform very close to native performance. Intel is also working a lot on the media pipeline. So basically when you're doing something like a video chat or like a conference show like right now, we're working on accessing all the native hardware in your system. For instance, you might have like native support for background blurring that's super efficient, or like auto framing, making sure that you're always in frame, or maybe even eye gaze correction. And even something as important and interesting as machine learning, we're bringing to the web. So a lot of this is part of what we call Project Fugu that Laura also mentioned. So one of the things you might be wondering, well, Intel is a semiconductor. You do chips and graphic cards and all of those things. Why do you care about the web? Well, it's kind of pretty basic. Like if we're mostly in desktop systems like Windows and Chrome OS, and we really want applications, because why would people use desktop systems if they don't have applications? So today, a lot of companies, like, you have to support a lot of different platforms. Mobile is very important. So maybe you need to support Android, iOS, Windows, Mac, Linux, Chrome OS, many different platforms. If you have to build a native application for all of these platforms, you probably don't have the skills, you can't find the skills, you probably don't have the money either. So you need something cross-platform. And what we have seen is that the web is really taking off. Like a lot of those applications are becoming progressive web apps. And some that maybe don't have the features on the web yet, those are like hybrid apps, maybe using something like Electron, or even like Ionic or Capacitor on Android or iOS. So it's really a winning strategy. If we look at the time spent on desktop systems, we see that around 65% is spent inside of a web browser. The number is actually bigger than that because a lot of the native apps like Slack and maybe Visual Studio Code are actually mostly web apps as well. And as you see, more than 60% of the developer community know how to use JavaScript. And even in 2021, last year, PWA adoption grew by 270%. Those are quite amazing numbers. If we dive a bit closer, I think this is very interesting to see people use the web a little bit more on the weekend. But if you look at the browsers, those are top apps on PC. Like Chrome is the #1 app this is on Windows. Then you have Edge. Then you have Firefox. Then you have Outlook, and Outlook is becoming a progressive web app. Then you have other browsers. Then you have Excel, and like all Microsoft 365, all of those are also becoming progressive web apps. So it's basically all web. But apart from just having like nice UI and all these like nice components, we talked about like you need all these different capabilities so that you can build these applications that people expect. And this is going really great. Like we're having like seamless paste and copy on desktop system today, frictionless access to local file using file system access, and safe access to external hardware such as web Bluetooth and the like. All of this is the Project Fugu effort. That is a project and effort shared between Intel, Google, Microsoft, and even Samsung Internet and others, where we're really trying to bring down the gap between native and the web. So one of the examples here is that, for instance, Visual Studio Code on the web using the file system access API can actually run directly in your browser. So that's pretty amazing. I can borrow my dad's computer and just type in, and I can get ready. Super amazing. Also, like an old application, a very important one, Photoshop. Like if they create a native app, if they want to be available, let's say on Chrome as well, they also support progressive web apps and Android apps. Well, they can be, because they can move to the web, and they have done that using WebAssembly. WebAssembly has made it possible to reuse a lot of the existing code, and the features we've been working on, such as like multi-threading, was essential as well. Halide is an important part of Photoshop, and Intel worked together with others on a technology called SIMD. It stands for single instruction, multiple data. That basically means that instead of saying like 1 times 5, you can multiply maybe a vector, like you say like 1 and 2 and 5 and 7. All of these values should be multiplied by 5 and 1 instruction. Adding support of that to the web has on average provided a speed of 3 to 4 times, and in some cases up to 160 times. That's pretty amazing. Another application here I think is very interesting. This is for education. So this is iRobot. You might know iRobot for cleaning your floor at home. They have this education tool. It's very nice. You can draw on paper and the like and program it directly in your web browser. And this works on every platform that supports web Bluetooth. So just connect through Bluetooth, and there you go. Super amazing. A lot of people are a bit scared about like, oh, right, this is kind of scary with all these like native apps and like web apps accessing these like powerful capabilities such as Bluetooth and USB. I actually believe that a lot of like native app kind of offers fake safety, because you might install them, but then they have access to everything on your system. They can do a lot of powerful, which you can't on the web. On the web, we're really working on making this as obvious as possible to what's going on and as safe as possible. For instance, you get a dialog and you click on the device you connect to, and that website doesn't know any other like Bluetooth devices around you. So we always try to improve on this. So and we'll constantly be innovating and refining our approaches. So what is the focus at Intel at this point? Well, our main focus in my team is working on capabilities. At Intel, we always say like no silicon left behind. And as the desktop is moving to the web, we need to make sure that's still the case. And then like performance, we really want like near native performance. And of course, we're optimizing, making sure that everything runs smooth on our hardware and uses this to its best abilities. So some of the things we're working on is, of course, WebAssembly, doubling down on SIMD support, multi-threading support, still maintaining WebGL is very important, used a lot out there, but also working on a replacement to WebGL called WebGPU. So here you're really working on the spec and implementation. And many times it's like, I think on average in the demos we've done is 3.7 times faster than WebGL. I find that's already quite amazing. And of course, like machine learning is super important. So we're bringing machine learning in the form of the Web Neural Network API to the web. And we're seeing amazing numbers. So one of the examples of what we're doing with SIMD is SIMD actually can work on different vector sizes depending on hardware support. So the spec in WebAssembly only support of sizes 128. That's basically 4 values of 32 bits. But we have like hardware that supports, for instance, 260, 56-bit SIMD. And now we can like automatically identify many of these cases and auto convert the code to use this other hardware without you as a developer making any change. And as you see here on the right, like even that it's in one case, it's even like 1.5% faster. So this is also pretty exciting. And we're just getting started with that. Also, the media pipeline, we've been working on the web codec API. So a lot of hardware supports, like, for instance, native AV1 decoders and encoders. So being able to use that in something like streaming, like I'm on StreamYard now, or using in say like Meet or Zoom is very important. And we've been working on that as well. But like performance is also very important. All our new chipsets using a hybrid architecture, also very known for mobile systems. So we have like efficiency cores and performance cores. So by being able to identify some of these threats, like here say signal, network, and worker, this is from WebRTC, we could make sure that these only run on, for instance, efficiency cores. And making that change, we save like more than 100 microwatts of power in Windows. And same thing with playback of video, making sure this works for every platform, like making sure that we're not doing a lot of like inter-process communication, cutting that down. So that's an implementation detail of Chromium works. We can, like, in this case, we save more than 10%. So this is just like an example of how we try to optimize everything on our hardware, but also it generally benefits any kind of hardware, a lot of these optimizations. Web neural network is extremely exciting. So, for instance, here we're looking at MobileNet, and this is with TensorFlow Lite. If you look on the left side, and there's the baseline that is XNNPAC delegate using WebAssembly and SIMD. So that's like 1. If you move to using threads, then you get to like a 3-time increase in performance, really good. But if you use our new WebNN, which is work in progress, you get 9.6 times better performance. And a native implementation is 9.8 times faster, so it's almost as fast as native. And this is across the board, really exciting. One of the partners we worked with is Zoom, so like they've been bringing that to Chrome OS as a progressive web app. So here working on web codec, making sure they can use the hardware we have available, but also working on like newer features that you can use without basically just like turning on a flag or setting a Boolean, would allow us to do things in hardware as eye gaze correction, lightning correction, noise suppression, and the like. Very, very exciting things for media. Personally, I'm working on compute pressure, and that's a new spec that allows you to know how the pressure of a system. So you can imagine, like, if you're doing a lot of different things in your computer, it might get a bit warm. It could also be using a lot of the camera. It might be throttling because it can't keep up. So sometimes that's not the best. For instance, if I'm in a meeting and I want to take meeting notes, it's kind of nice to be able to type and not having like, oh, why nothing is happening while I'm typing? And then suddenly you see a lot of letters on the screen. So as an application, being able to maybe adjust the number of video feeds, adjusting resolution, removing unneeded features like for instance, filters, this is very important. So we're trying to come up with a very nice API that's very high level. So you just get like a state, like if it's barely being used, it will be called nominal. That's the pressure state. If it's normal usage, it's called fair. If you're doing pretty well, but you can still keep on going, but don't do more work, it will be serious. Critical, yeah, maybe now you should try to do a bit less, otherwise the system might be stressed. So very simple API. Here's just one example to show how to use it. I won't go into detail because of time. And with this is basically like the conclusion of what we're doing at Intel. We're really trying to improve what you can do on the web by making sure that no silicon is left behind. Everything is optimized for our hardware, and making sure to always provide the best performance for web apps and getting access to all those nice capabilities that you have on your systems. But what is really important is that this is a journey we're doing together with you, the developers, and we really want to collaborate with you. So this is both in like the standardization organization, the World Wide Web Consortium, but even on Twitter or today on Discord, like get in contact with me if there's anything you want to talk about, if any feedback, I'll try to connect you with the right people. And with this, like I'll say, let's win together. The web is doing great, and enjoy this conference. Very nice talking to you. Bye.
Wow, that was a massive amount of information. I personally learned a lot, both about technical side of progressive web applications and about what developers think about PWAs these days, and about what companies think about PWAs. What about you, Diego?
Likewise, it's been definitely a lot of information, very useful, and I think one of the outtakes is that the future of PWAs on the web is really getting really interesting. Like the more we bridge the gap with platform-specific apps, then the more use cases we're going to be enabling. And I find it really inspiring, like all the things that are coming to the platform. So yeah, this is actually the end of block 1, but this is just the beginning of the PWA Summit for this year. There are 2 more blocks with workshops and sessions that are coming, so stay tuned, and thanks for joining.
Yeah, and meanwhile, between the blocks, let's stay connected. Please send your feedback on Discord, tweet about PWA Summit on Twitter. Let's keep this connection going. And
we are around, and we're waiting to hear from you.
Yay. Then thank you very much. Bye.
Yeah.
Charlie like it, look curly like it. Whoa, banana, you know Ayla like it. Paul Van Wageningen like it. Whoa.